In the previous lessons on deep time, we learned that scientists can get the ages of fossilized organisms by measuring the age of volcanic ash layers above and below the specimen of interest. And volcanic ash can be dated because volcanic ash has zircon crystals in it, and the zircon crystals have a structure, an atomic structure, including zirconium atoms, but sometimes uranium atoms can replace those zirconium atoms, and uranium atoms decay into lead atoms at a known rate. So these little zircon crystals are like little clocks, and they can be used to measure the age of a volcanic ash layer, and so nail down the approximate age of any fossil found in between volcanic ash layers. When Darwin was pondering Glyptodon here, he speculated that perhaps Glyptodon was the extinct ancestor of the modern armadillo, but he had no way of really nailing down how old this fossil was. How long would it take for the ancestor to evolve into the modern armadillo? Well, with modern radioactivity dating techniques, we can sort of start to assign some ages to some of these fossils. And in this lesson, we're going to tell the story of the vertebrates. And what does the fossil record say about the vertebrates? Now, vertebrates are organisms with backbones. There are 5 major groups. We've got the fish, amphibians, reptiles, mammals, and birds. And you find fossils in sedimentary rock. There's a picture of the Grand Canyon, and these rock layers were deposited over time and then eroded by the Colorado River. So if we look at one of the walls of a canyon, we see these layers, these rock layers. Now they're formed from sediments that have hardened into rock, and because more recent sediments are deposited on top of pre-existing sediments, the deep rock layers are older than the shallower rock layers. So fossils in the deep layers are older than fossils in the shallow layers. Now that's a measure of relative time. We can say that fossils in the deep layers are older than the ones in the shallow layers, but we're not giving exact ages. In order to measure absolute time, the absolute age of a rock layer, we have to use the radioactive dating techniques. So we're going to ask the question then, when did the vertebrates appear in the history of life on Earth? How old are the rocks that have vertebrate fossils? So then let's use the different rock layers here to paint a picture about when the different vertebrates appeared on Earth. Well, if we look at the youngest rock layers, so the upper layers up here, we find fossils of all of the 5 different vertebrate groups. We have representative fish and amphibian, reptile, mammal, and bird fossils in the youngest rock layers at the top. And here are the 5 pictures then. Now, as we look at fossils in layers just below those layers, we lose the birds, but we have all the other 4 major groups. If we go a little deeper and look at the fossils in the deeper layers, we lose the mammals, but we have the other 3 remaining groups. If we go still deeper, we lose the reptiles. If we go deeper still, we lose the amphibians, and these lower layers then only have fish fossils. So at one time in the distant past, the only vertebrates on Earth were fish. Now this, to Darwin, suggested an astounding inference that fish were the ancestors to all other vertebrates. And the fossil record then supports this idea, because what we see over time is new vertebrates appearing in the fossil record, with birds being the youngest and fish being the oldest. Now Darwin, of course, is going to argue that this is an example of evolution, that fish evolved into the other groups of vertebrates. But what came before the fish? What do even deeper rock layers tell us about life on Earth? And here then we find organisms without backbones, for example, fossils of trilobites. Now, we're not suggesting the trilobite was the ancestor of fish, but the idea is there were other animals without backbones, some of which were the ancestors of fish. So we have here then an incredible story that the fossils in these rock layers are showing us that vertebrates evolved over long periods of time. But while the layering here gives us relative time, so we can say birds are the youngest vertebrate group and fish the oldest, it doesn't tell us the absolute age of these major transitions. When did fish evolve into amphibians? When did the amphibians evolve into reptiles? When did the reptiles evolve into the mammals and then the birds? When did that happen? So what we need to know is the exact dates of these layers of the rock. And that's what radioactive dating techniques can provide. And when you date these rock layers, you find that these ancient fish, the ones that evolved into all later vertebrates, were living around 500 million years ago. So 500 million years of evolution produced all of the vertebrates. That is deep time. It's hard for us to grasp how long a time that is. And so if you're wondering, well, how can a fish evolve into all the different kinds of vertebrates on Earth today? Well, 500 million years is a very long time for a natural process to create such a diversity of organisms. Now, the 500 million year story of vertebrate evolution, that sounds like a long story, but you'll recall that the Earth is 4.5 billion years old. So the evolution of vertebrates occurred over a time scale that was just a fraction of the time scale of the Earth itself. Now, we're going to use this diagram here to give us a sense of this deep time. Here, imagine you extend your arm from your shoulder. So actually the shoulder, the upper arm would be over here in this part of the diagram, and then here's the lower arm, and then the wrist and the hand and the fingers, etc. Well, imagine then at the shoulder, as you extend your arm, the shoulder would be the time when the Earth first formed, 4.5 billion years ago. And as you extend your arm, then the tip of the finger would be the current time right now, present day. Well, the 500 million year story of vertebrates would be the length of from the knuckle here out to the fingertip. That's about 500 million years. Notice then there was a lot of time before the vertebrates. And if you sort of look at other fossils, even in deeper layers, you can find fossil organisms that are 2 billion years old. And in fact, even older fossils reaching back to 3.5 billion years old. But these are tiny little single-celled organisms. The big animals made their appearance around 600 million years ago or so. And the vertebrates then start their story around 500 million years. Notice the humans. We would be at a location right at the tip of the fingernail. Should we use a nail file to trim our fingernails, all of human history would be wiped out. So humans are a very recent addition to the diversity of species on the planet. And this is the concept of deep time then. Everything we know about human history is just a tiny little fraction of the entire history of life on Earth. The Earth is tremendously old, and it has been the home to an incredible story, the evolution of life on Earth. And we'll tell the rest of that story throughout the course. And here goes all of human history.